questions, try to solve them, and if you need help, please let me know. Now, let's take also more examples about the wholes and about the horizontal asymptote. Now, look to this one here. So, the same idea. Now, let's find the domain. Let me zoom in a little bit. So, now let's find the domain. The domain of this one, we take the denominator equal with 0. So, of course, I have x is equal 0. Now the domain will be from negative infinity to 0, union from 0 to positive infinity. Okay? Now let's reduce. As we can see, can we simplify the numerator with the denominator? No, I can't simplify. You can't just say cancel this with one of the x's. No, this is wrong because there is minus sign here, so you can't just simplify this. Okay, if you want to simplify this, okay, let's say example, if you want to simplify it, I will just help you with this without, this is not reduced, okay, but let me help. As you remember, we are lover. Do you remember the lover part? Okay, I explained it in the class, so we can just take 3x over x cubed minus 4 over x cubed. So we can now cancel 1x from 1x here, so it become 3 over x squared minus 4 over x cubed. So if you reach this one, I can't simplify the question more than this. So as you can see here, the degree now it becomes different, and everything it becomes different. So you don't have to do this step because the question will become more complicated. So now, because you can't simplify this, now let's go to the second one. So we just say reduce no holes. No holes because there is nothing simplified. Now intercept. I need to find first y-intercept. Now to find the y-intercept, put x equals 0. Now if I put x equals 0 here and x equals 0 here, this one will cancel, so, and this one will become 0, so negative 4 over 0. Okay, so this does not exist, right? Because we can't divide number by this one, and x is equal 0, so as you can see, the domain, the excluded value x equals 0. Of course, we can't have intercept as x equals 0 because the x equals 0 is the excluded values. We just say no y-intercept, okay? No y-intercept because the value that I have here, or the value that I found, is the excluded value from the domain. Now, the next one is to find x-intercept. To find x-intercept, I need to set y equals 0. So if I take only the numerator equals 0, so it will be 0 equal 3x minus 4. Now to find this one, we need to plus 4 for both sides. So it become now 4 equal 3x divided by 3 divided by 3. So x is equal 4 over 3. Now, if I need to tell you where is 4 over 3 on the x-axis, so it should be here. As you can see, this one is 4 over 3 and 0. So as you can see, no y-intercept, but there is one x-intercept represented on the graph here. Now, how about the vertical asymptote? The vertical asymptote, as we mentioned, is similar as the domain, but as you can see, because the domain is x not equal 0, which is the excluded value, so the vertical asymptote will be, we have vertical asymptote at x equal 0. If I need to graph it, okay, the vertical asymptote, it will become at x equal 0, which is this one here. So this is x equals 0, the vertical asymptote. Now, how about the horizontal asymptote? Look to the degree here. The degree of the numerator is equal 1, and the degree for the denominator is equal to 3. So we just can say that the numerator is less than denominator by 2 different degree. We can say that y is equal 0. So the horizontal asymptote, from the rule that we learned, when the denominator is greater than, so the horizontal asymptote is y equals 0. Y equals 0 is on the y-axis here, as you can see. Okay, the graph will go close from the horizontal asymptote. The same thing on the other one. It's intersect, but then it goes more close to the graph on the right side. Okay, now let's take one more example here about this one here. Now, if you look to this question, you can see the question is a little bit confused because it's not simplified. So first thing, as you can see, the numerator is a quadratic. So let's factor the quadratic here. Okay, to factor the quadratic, the factors of a 20, as you can see, it's let's say 2 and 10, which is 20, and 5 and 4. 5 and 4. So the numerator, it's easier if we take it as x plus 4 and x plus 5. So I think this is easier to us. Now let's find the domain. The domain x, we take the denominator equals 0. So x minus 4 equals 0. That's mean x is not equal, sorry, or x equal 4. I mean the domain, the 4 is the excluded value. From negative infinity to 4, then union from 4 to positive infinity. Now how about the reducing? So as you can see, can I simplify or cancel anything from the numerator and denominator? No. So we can just mention that there is no wholes. Okay. Now intercept. Let's find y-intercept. To find y-intercept, we need to put x equals 0. And to put x equals 0, if I put this one 0, this one 0, and this one 0, so it becomes 4 times 5 is equal to 20 over negative 4. So the answer is equal negative 5. We can just say the y-intercept is equal negative 5, or we can just mention 0 and negative 5. And if we look to the graph, 0, negative 5 is here. Okay, this point here is 0 and negative 5. Now, how about the x-intercept? So to find x-intercept, we need to set y equals 0. We take the numerator, and because we factored the numerator, it's become easy now. So 0, x plus 4, and x plus 5. So the first 0 is x equal negative 4. The second 0 is x equal negative 5. So as you can see, the zeros, it become at x equal negative 5 and negative 4. So this one here should be x negative 4 and 0. And on the other one here, it should be negative 5 and 0. Okay, I know it's not clear to you, but because the graph is zoom out, so that's why it's not clear. But if I zoom in, you will see the point here. You can graph it in decimal and you see the 2 points. Now, how about the vertical asymptote? As we know, the vertical asymptote is the same as the domain, which is the excluded value. The excluded value here is 4. The domain here, the excluded value is equal 4. So the vertical asymptote at x equal 4. And if we need to graph it, vertical asymptote 4, it should be somewhere here. So this one is the vertical asymptote, okay, at x equal 4. Okay, now how about the horizontal asymptote? The horizontal asymptote, we look to the power, to the degree. And as you can see, x here is x to the power of 2, and here is x. Okay, we can just say that the numerator is greater than denominator. So we just say no horizontal asymptote. But is the difference 2 is greater than 1? Is the difference is 1? Yes. So there is, we can just say there is oblique asymptote. There, okay, is oblique asymptote. How to find now the oblique asymptote? Now to find the oblique asymptote, you have to do the long division. If you don't know how to do long division, do the synthetic division. It's up to you. But the synthetic division, to do it, you need to use the factors, okay, or sorry, you need to remove the variables, okay, but the long division, you can just multiply both of them. Now let me try both of them. Let me do both of them, the synthetic and long division. First, let's do the long division with you. Long division is x minus 4, it should be the divisor, and x squared plus 9x plus 20. Now let's simplify this. So we take the first term divided by the first term here, divided by x. So the answer should be x. Then we distributive property. So it become now x squared. Okay, x squared, then x times negative 4, negative 4x. Then we minus them. The first term always cancel. Then 9 minus 4x, it become 13x. Then we take this one down, positive 20. Then we divide the first term by the first, okay, so it become 13 only, so plus 13. So now we do the same thing, we repeat, we distribute, so 13x, we minus, then 13 times negative 4, which is equal to negative, is 52. Now let's minus them. Okay, so the first term is cancelled. Now the next one, 20 minus 52, so it become positive, so the question is equal 62. Now if I need to take the answer, always here ignore the remainder. We are not going to take the remainder, just ignore it. It's like never been here. Okay, now the answer, you know that the answer is only the quotient, right? So the quotient is the answer. So we know that, and the oblique asymptote, okay, what type of function is this one here? It's a linear function, which is mx plus b. So the oblique asymptote is a linear function, but they give it a different name as oblique, but the linear function is same as oblique. Now if I ask you to graph 2x plus 3, how to graph this one here on the x and y axis? You would say we start from the y-intercept. Y-intercept is equal to 3. This is a 3. Then we take the rise, which is the slope over next to the x, which is rise over 1. Okay, 2 over 1. So from starting from the y-intercept, 2 step up, 1 step to the right. So the horizon, the oblique, or the linear, it will be like this. So now if you look to the quotient, which is x plus 13, this is a linear. Okay, x plus 13 is a linear. So now if I need to graph this linear, we start from the y-intercept. Okay, so the y-intercept is equal 13. Now where is 13? Let's say this is 10. 13 should be somewhere here. Okay, then 10, 12, 14, 16, 18. So let's say it's one step little bit up. Okay, so 13, it should be here. Then it's saying the rise over 1. Okay, look to the graph. The rise over 1, it's 1 over 1 because there is no number. So 1 step up. Okay, then 1 step to the right. So the same thing, 1 step up, 1 step to the right. Okay, and 1 step to the right. 1 step up, one step up, then one step to the right. Okay, sorry, because we are moving 2 steps, 1 up, 1 to the right. So the graph, the other point should be somewhere here. Okay, on this one here. Now if I need to graph my line, it should be like this, as you can see. This one is the oblique asymptote. If I complete the graph, it should be something like this. So this one here, this line represents the x plus 13. Okay, and this is, as you can see, the graph is my function. It's going close to the oblique asymptote, as you can see here. So this is how we can find the oblique asymptote. If you want, you can use the synthetic division. If I need to use now synthetic division, let me use it. So let's take the factors, which is 4, because x is minus 4. I take x equal 4. Then here I take the factors. The first factor is 1, then 9, then 20. Then if I need to do it, take this one down, so it will be 1. Then 1 times 4 is equal 4. 4, and we add 9 plus 4 is 13. 13 times 4 is equal 52. Then we add them, so the answer is equal 62. So as I told you, we ignore only the last one and we take this one here. And always here should be x, okay? And here plus 13. So as you can see, it's 1x plus 13. So this is the linear function. Now start graphing with the same thing. So the same thing that we get here. I hope you understand the oblique asymptote. Okay, now here we have the last example about if you have some holes. If you look here to this example, the domain is x minus 1 and x plus 3 equals 0. Okay, so x minus 1 equals 0, x equal 1. X plus 3 equals 0, so x is equal minus 3. So as you can see, the domain is from negative infinity to negative 3 union, okay, from 1 to positive infinity. Now how about reduce? As you can see, I have here x minus 1 and I have here x minus 1. So can I cancel x minus 1 with x minus 1? Yes, I can cancel them. So the function will become x plus 4 and x plus 1. And because I cancelled the term x minus 1, okay, from which is reducing, so I have whole, okay, I have whole at x equal 1. Okay, I have whole at x equal 1. So where is x equal 1? So let's say this is 0, so 1 it should be here. So the function will go continue here, and there is a hole here and the function will complete here. Okay, so there is a hole at this point here, so there is discontinuity at this point here. Now intercept, so let's find the intercept. So to find y-intercept, I have to set x equals 0. So if I set x equals 0, so the y-intercept is equal 4 over 3. So that means 0 and 4 over 3. So what is 0, 4 over 3? This is 0, this is 4 over 3. So this one here is the y-intercept, 4, 0 and 4 over 3. Now, how about the x-intercept? So to find x-intercept, and change the color, x-intercept, let's set y equal 0. So now if I set y equal 0, because we cancel this, so I don't have to use the original function. I can use only the simplified one. Okay, so you don't have to use the original one because I already simplified it. So take x, we take the numerator equals 0, x plus 4 equals 0. So x should equal negative 4. So we just say negative 4 and 0. So this one here is the x-intercept, negative 4 and 0. Now the vertical asymptote, we know the vertical asymptote is same as the domain. But as you can see here, because I canceled the one and the function it become this one, so the vertical asymptote, it's not 1. It will not take 1 because 1 is simplified. So the vertical asymptote, it's only the negative 3. Vertical asymptote at x equal negative 3. Okay, and this is what you can see in the graph. This is vertical, this is negative 3, it should be here. Okay, this is x equal negative 3 at the vertical asymptote. Then the horizontal asymptote, look to the power. As you can see, this is 1 and this is 1. So the numerator is equal the denominator. So we take the coefficient. So the coefficient here is 1, the coefficient here is 1. So y is equal 1 over 1. The horizontal asymptote is equal 1. Okay, and as you can see, 1, this is 1, and this one here is the horizontal asymptote. Okay, which is y equal 1, horizontal asymptote. Okay, now we're done from all the examples. I hope you understand this. It's your turn. Try to solve these equations. Complete now with the second part of the lesson, rational equation. Now, the rational equation, which is we're talking about when we have a equation with 1 over a variable x. Okay, so how we can solve this one? Let's read here. Okay, rational equation involving fraction can be solved by what? By multiplying each term, okay, in the equation by the least common denominator. So we need to multiply, as you can see here, multiplying each term. So all the terms in the equation, I have to multiply them by the least common denominator, LCD. Okay, what's the LCD here in each rational equation? The LCD is the denominator. Means, look to the all term in the question. I have this term here, and I have this term here, and I have this term here. So you have to look to the all terms in the equation from the right side and from the left side. Then you have to look to the denominator. Okay, so what is the denominator given in the question? Is x minus 8. So it's only x minus 8 is the denominator in the all three terms. So the LCD is only the equal x minus 8. Now, as mentioned here, by multiplying each term in equation by the least common denominator, so I have now to multiply x minus 8 for every term. So x minus 8 multiplied with the x minus 8 multiplied with this term, x minus 8 multiplied with this. Okay, so this is what you can see here in this step. X times x minus 8 plus 6 over x minus 8 times x minus 8 equal 0 times x minus 8. Now what I have to do, don't forget we have the rule that if I have anything in the numerator can be simplified, okay, with the thing in the denominator. For example, like this one here, if I have x minus 3 here, I can cancel it with x minus 3, so it's remain x plus 2, okay, over x minus 1. So the same idea here. Now, first step, the first one is distributing x times x squared. X times negative 8, negative 8x. Now, in the second term, x minus 8, cancel x minus 8, so it's remain what? 6, so 6. Equal 0 multiplied with all of that term is still equal 0. Now if you look to this one here, this is a quadratic function. which is a quadratic function. We need to find the factors of 6, then can be added to get negative 8. The factors of 6 is 1 and 6 and 2 and 3. So none of these can be used to factor this. So what I have to do, I have to use the quadratic formula. The quadratic formula is negative b, positive negative square root b squared minus 4ac over 2a. So this is the formula of the quadratic. So if you don't know how to factor, or the question cannot be able to factor, just use the quadratic formula. Okay. Now the second step. The second example. Look to this one. As I told you, we need to look to every denominator for all terms. What's the denominator here? What's the denominator here? What's the denominator here? Okay. And we find, so LCD, the least common denominator. So I have x minus 4. So this is x minus 4. Okay, in this term I have x minus 2. So you take x minus 2. In this term I have this quadratic function. So when you have a quadratic function, try to factor this quadratic function. So what the factors of this quadratic function? So the factor is this is x minus 4, okay, and x minus 2, right? So as you can see, x minus 4 and x minus 2 is repeated here and is repeated here. Okay, so I already took x minus 4 and x minus 2. So you don't have to repeat the 0. So if the variable, or let's say if the term is repeated, okay, don't take the repeated, just take it one time. Only one time you take the denominator. Okay, now the least common denominator is x minus 4, x minus 2. Let's multiply now this this is least common denominator with this term, and with this term, and with this term here. Okay, now let's multiply them. So the first one, 4x squared minus 6x plus 8, okay, multiplied with x minus 4 multiplied with x minus 2. Okay, then equal 3x over x minus 2 multiplied with x minus 4 and x minus 2. Then plus 2 over x minus 4 multiplied with x minus 4 and x minus 2. Now just cancel the terms. Okay, if you look here, the first term I write the quadratic. So now let's write the factored form, better than writing the standard. So the factored form, it was x minus 4 and x minus 2. Now cancel any terms that in the numerator, same in the denominator. So x minus 4 and x minus 2, cancel x minus 2. So it's remain only what? 4. So this side is equal, 4 is equal. And this side I have x minus 2 and x minus 2. So it's remain 3x multiplied with x minus 4 only. Plus x minus 4 cancel with x minus 4. So 2 multiplied with x minus 2. Now use distributive property to simplify this more. So 3x multiplied with x is equal to 3x squared minus 4. Sorry, not minus 4. 3x squared. Now 3x multiplied with negative 4, it's negative 12 plus negative 12x, okay, plus 2 times x, 2x, 2 times negative 2, negative 4. Okay, so as you can see here, this is a quadratic function, so I need to simplify this at the like term to make it as a quadratic. So the first thing I have negative 12x, positive 12x, so it becomes 3x squared negative 10x minus 4. Then let's add plus 4 here, so not plus 4, minus 4. Okay, so now that's minus 4 here, minus 4 here to cancel this one, so it becomes 0, 3x squared minus 10x minus 8. Now let's factor this one to find the 0. So the first one, to factor it, we need to multiply 3 multiplied with negative 8. So x squared minus 10, 3 times negative 8, negative 24, equal with 0. Okay, now after I find this, the next step is to find the factors of negative 4, negative 24, that can be added to get negative 10. Okay, I have 1, 24, I have 2 and 12, and I have 3 and 8. I think I don't need to find more because it's 12 and 2, and it should be negative 12 and positive 2. So now x minus 12 and x plus 2, okay, equal 0. Now after I find the factors, don't forget to divide by the number that we multiplied. All the students always forget this. Divide by 3, divide by 3, so x minus 4 and x plus 2 over 3 equals 0. So the first x is equal 4, the second x is equal negative 2 over 3. Okay, so now I have this equation here, I have these two x's. I need to do now to check from which one is the correct answer. So just take this 4, replace this 4 in every x here, replace x4 here and here, here and here, and check the answer. If the right answer equal to the left answer, so it's correct. If this one here is not equal this one here, so if they are not equal, so it's not an answer. So you have to do the same thing with negative 2 over 3. You have to replace it in every x and check if they are correct. So maybe one of them is correct, one of them is not correct. So you have to check both. Okay, I hope you understand this. Now, this is a question to practice on. So practice, and if you need help, please let me know. And also to get full power, try to solve this question in this page. Have a good day. See you. Bye-bye.